Hi everyone. So this is our last chapter. Chapter 8 is on complex numbers. So our first section in 8.1 is pretty much reviewing what you know about complex numbers from Algebra 2. Okay, so I would be the square root of -1. So a complex number is a number in the form of a plus bi, and a is the real part and b is the complex part. So an example of that would be like 2 plus 3i. If it's a pure imaginary number, that means it doesn't have an a, so it's just bi. So like 2i would be a pure imaginary number. And we're going to use the conjugates. So remember that is when it's like plus and minus of the same thing. So let's take a look at that chart on the bottom. So here we're listing pairs or powers of I. So we know that I is just equal to I. And we know I squared because that was one we did a lot in Algebra 2. So I squared is equal to -1. So I to the third would be I times I squared. So -I. I to the fourth would be I squared times I squared. So +1. So that pattern you can use to figure out like I to the 150. And we're going to do a couple examples like that, but it keeps repeating. So every 4, it's the same. So if I squared is -1, I to the 6th would be -1 because it's 4 more, and 4 more than that would again be -1. So if I to the third is -I, 4 more would be -I, 4 more would be -I. So the pattern just keeps repeating. So as you go up, it'd be either the first is I, second -1, third, and then it just keeps going over and over again. So we're going to use that pattern to help us find other ones. So let's start looking at our examples. Okay, so first we got the square root of -100. So I know you guys are like, oh, that's 10i, which it is. I just want to show like the process. So first, if you have a negative in the square root, you're supposed to take out the negative before you do anything else. So you would have the I root 100, and then you can work on the radical after that. So the square root of 100 is 10. So it is just 10i. But it's important that you do that for problems like this one. So let's look at this one. So you know it's going to have an I because the negative, and then if we reduce, we have 2 sets of 2's in there, so we would end up with 2i root 2. So let's look at the multiplication one. So if we take the I out from both of them, then we'd have I squared times root 49. I squared is -1, root 49 is 7, so we end up with -7. Okay, so why don't you try these two, and then when you come back I will show you the answers. Okay, so we got 2i root 3 for the square root of 12, and then this one we take our i's out, so that becomes negative, and then the 60 can reduce to 2 root 15. So we end up with -2 root 15. So for the division ones, it's pretty much the same idea. I would take out the I first, so then we have, or I times the square root of 48 over 24, which is just 2. So just be I square root of 2. And then here, if you take the i's out, leave it as a fraction, or you could have put it in 1. The i's are going to cancel, so you have root 20 over 2, which would just be the square root of 10. So this one is like how you would simplify the quadratic formula. That's why that's there. So why don't you go ahead and try to reduce that radical. You got to make your factor tree, and then I'll show you how to do it when you come back. Okay, so we end up with -8 plus 8i root 2 over 4. You make the whole factor tree for 128. That's how I got the 8 root 2. So then last step here would be to reduce those 4s and with the 8s. Since they're both divisible by 4, we can divide it out. So we would end up with negative 2 plus 2I root 2. Okay, so let's look at the bottom example where we have to solve. So this is a quadratic, but it doesn't have all 3 parts. It only has the squared part and the number. So that means we can solve by taking square roots. So I would subtract the 100 first. So we have 4x squared equals negative 100. Divide out that extra 4 that's there. So x squared equals negative 25. And then to get rid of the squared, we take the square root. So x equals plus or minus the square root of negative 25. And now we can do our I stuff with that. So plus or minus 5I. Okay, so let's check it out up here. So for this one, it's a quadratic again. Try to factor. So factors of 45 that make negative, that make negative 6 don't exist. So that means we'd have to use the quadratic formula. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So plug this in. So we get negative 6 plus or minus the square root of negative 6 squared minus 4 times 9 times 5 all over 2 times 9. So let's simplify this. So we have 6 plus or minus the square root of 36 minus 180 all over 18. So that would be 6 plus or minus the square root of negative 144. So now we can take the square root. And then the only thing else would be to simplify the fraction so each part can be divided by 6. So we have 1 plus or minus 2I over 3. And that would be your final answer. So for our next example, all we're doing is foiling because we have 2 parentheses next to each other, so that's times. So remember, we got to distribute to both pieces. So that would be negative 6 plus 12I. In the middle, we got negative 9I, and then 18I squared. So let's simplify this. We can add those like terms in the middle. So negative 6 plus 3I. And then negative I, remember, I squared is negative 1. We can change it to negative 1. So we're really subtracting 18. So now we have like terms again. So negative 6 minus 18 is negative 24 plus 30I. Okay, so let's try the next one. So for this one, I know it looks like kind of like the last one, but you got to check the middle. It's adding here, so we're not foiling. So add the like terms. So 5 and negative 2 would make 3, and 7I plus 6I would be 13I. And that would be it for that one. So make sure you look and see, because everyone always tries to foil these, but it's not foiling. Okay, so for the next one, just like we can't have square roots in the bottom, we can't have i's in the bottom. So we would need to times it by the conjugate to get rid of that I in the bottom. And then we have to do it to the top too. So now we have to FOIL. So okay, so we FOILed. Now we can simplify. So up top we have some i's, so that would be 15 plus 13i plus 2 times negative 1. Change that I squared. 25 plus 0i, I squared would be -1. So negative and negative would make it +1. So 15 minus 2 is 13 plus 13i over 26. And then we have a common factor of 13, which we can reduce. Okay, we're almost done. So this example, we're using some of those power rules we talked about on the front, but there's also some exponent rules here. So if our exponent is negative, then we're going to drop it down to the bottom. So now we would have 1 over I to the third. And then I to the third on your front says that it's -I. So this would be 1 over -I. But we can't have i's in the bottom. So times the top and the bottom by I. So we would have I over -I squared. So I over -1. So this would end up just being +I. Okay, and so now this one is one where we have to kind of reduce it. So remember, every fourth power, the things repeat. So if we figure out, take away fourths from there, then we'll see what it equals from I to I root 4. Okay, so you could just keep subtracting 4s from that to get it down to its lowest one. If it's a really big number, that isn't really probable, you know. Or you can subtract powers of 4, so like you could subtract 12, and then it would be I to the third, which is pretty much what we're going to do. Sometimes that might not be probable either, so the other way would be to do long division and see what the remainder is. So how many times can 4 go into 15? So it's 12 with a remainder of 3. So this turns into your power, so this would equal I to the third. So remember when I just said how you can just keep subtracting 4s? So if you subtract 4 3 times, you get 3, so the remainder is 3. So that's how you would reduce it. So then I to the third equals -I. So that would be your final answer. So another problem like that would be like I to the 201. Okay, so you could subtract things at powers of 4. So if you know like 60 is divisible by 4, you could subtract 60s from there. Or I just picked that 80. I just picked big numbers that are divisible by 4. Or we can do the long division way. So 201 divided by 4. So 4 can go into 25 times. That would be 20. 0, so bring down the 1. So our remainder is 1. So this would be equal to I to the first, which is just I. So that would be another example of how to do that. So I like the long division way because your remainder is your power. But you could have subtracted 200 because 200 is divisible by 4 as well. So you're really looking for powers of 4. So that's it for 8.1. So make sure you write down any questions and we'll go over them in class tomorrow. Warner out.